Okay, so we're going to have a quick look at integration by parts. So sometimes if you're trying to integrate a function which is a product of two expressions in terms of x, sometimes you can expand them and simplify them and integrate that way, but other times you need to use integration by parts. Okay, so an integration by parts formula is given to you in the formula book. It's basically derived from the product rule for differentiation. Okay, so what we need to do when we do integration by parts, if you look at this example here, so our two functions that are multiplied together are x and cos x. So basically, as you can see from the formula, we need to pick one of those functions to be u and one of them to be dv by dx. So then one we're going to differentiate, we're going to differentiate the u, and we're going to integrate the dv by dx. So for our u expression, we need to pick one that will become simpler when it's differentiated. So in this case, we'll say u is x. Okay, if we differentiate that, you get du by dx is 1. And if we say dv by dx is cos x, then obviously if we integrate that, then we get sine x. So now we've got u, v, u dash and v dash. We can sub those into the rest of our integration by parts formula, which gives us x and sine x, then minus the integral of sine x times by 1 dx. And then obviously that integral is now much more simple because it's just integrating sine x. Sine x integrates to negative cos. So then when we simplify, we just get x sine x plus cos x plus c. Okay, so a fairly straightforward example of integration by parts. Next one, sometimes you get questions where you have x squared and ln of x. Now obviously if we differentiate x squared, it will become a term in x, which is slightly simpler, but not quite as simple as if we treat u as being ln of x, because then when we differentiate that, it becomes 1 over x, so that everything's in terms of x, and everything will simplify down quite nicely. So if we say u is ln of x, u dash is 1 over x, v dash is x squared, so v is x cubed over 3. Okay, so again, then we just sub those into our formula. We get ln of x multiplied by x cubed over 3, take away x cubed over 3 times 1 over x dx. Now obviously, this bit here in the integral is now much simpler. We can simplify that down to x squared over 3. And we can obviously integrate that reasonably straightforwardly, so it will become x cubed over 9. And then remembering to add the c once we finish integrating. Okay, sometimes integration by parts, you have to use it twice, which is obviously even better. So in this case, we can't simplify e to the x by differentiating it. So what we can do is make x squared slightly simpler by differentiating it and turning it into a linear expression. And then we integrate again using parts to make it down to a constant, which is then obviously easier to integrate. So if we start off by saying u is x squared, okay, so du by dx is 2x, v dash is e to the x, so obviously v is e to the x as well. So if we put those into our formula, we get x squared e to the x minus e to the x times by 2x. So now if we simplify that, now we still have to use integration by parts on this integral, but it's a bit simpler now because we've got an x instead of an x squared. So if we now look at just that integration on its own, so again we're going to use parts, we'll say u equals 2x. You could take the 2 outside the integral. So u dash is 2, then if v dash is e to the x, then v is e to the x as well. So if we substitute that into our integration by parts formula, we get that, which simplifies down, and we can integrate quite easily. So we get this. So we know that the integral of 2x e to the x with respect to x is this here. So what we can do now is sub that in where we had that. So if we just substitute that in and then simplify, being careful about your plus and minus signs, then that is our final answer. That's using integration by parts twice. And the last one we're going to look at is a slightly more interesting example. So here, if we have e to the x sine x, sometimes you get these sorts of questions where neither term is reducible by differentiating. So what we're going to do instead, you can pick either one for u and v dash, okay? And we're going to do integration by parts twice, and then there's a little twist. So same as before, we say u equals e to the x, so u dash is e to the x. So v dash is sine x, so v is minus cos x. Put that into our formula, we get this. So going through a bit quicker now. And now we're going to integrate this using parts again. So same sort of thing, and we come up with that. Okay, so now what we can do, if we now look at this term here, that's actually the same as what we started off with. So if we add that to both sides, then we get 2 lots of our original integral equals e to the x cos x plus e to the x sine x plus c. So then we can just divide it all by 2, which will give us that as our final answer. Okay, so if you differentiate it twice, so integrate it twice, then you'll get back to the integral you originally started with, and then you can just add that to both sides and divide by 2. That's integration by parts, and I'd recommend you go away and do some practice, because that's how you remember all these tricks.